All right, hello everybody, and welcome back to episode 33 or 34 of Coding Until I Get an Embedded Internship. Today will unfortunately be very short, probably like max 20 minutes. I don't think I can go any longer than that today, unfortunately. Unfortunately, today was a little bit busy for me. Sorry about that. So yeah, probably won't be doing much today. However, I promise you, I'll probably do more through the week. So yeah. Let me first set everything up here. So let me do this. Tab. Okay. So let's get started. I'm gonna get Visual Studio. So last time we tried to do Wi-Fi, we didn't get far. So probably we might do it. Continue today. So yeah, let's begin. So here's what I'm thinking, right? Since we probably won't be doing much Wi-Fi today, I want to let me look at the roadmap again, the embedded roadmap. All right, so we finished. We understand more so about UR I squared C. Those are the main things that we need for sure. Covered a lot of the main stuff for microcontrollers. So I think now that I think about it, I think I might just move on to my project, which we just need to do cover like Wi-Fi stuff, right? Wi-Fi, and yeah. So yeah, so let's do that. I will probably actually no. Here's what I think. I think probably should learn JTAG because that's probably I don't know what JTAG even is. So
and forged knives to my dorm room and built a Wix website to sell them. I'm Noah Rosen, founded on a report.
Hi, this is Brian Joseph Ross, and today we're going to talk about what JTAG is and why we should use it. The term JTAG covers quite a lot of territory, but for the purposes of this presentation, focus is on the IEEE 1149.1 standard, which defines the test access port. Corellis is a company that utilizes components in JTAG devices.
32.
Hi there. In this video, I will show you how to debug your ESP32 IDE application inside Visual Studio Code. We go through the steps to set up and configure an external debugger and how to make it work reliably. Let's get started. Hi, I'm Yuria, and this is my second video of my ESP32 series. In my last one, we have learned how to use the ESP IDE framework on Visual Studio Code. By the way, thanks to everyone who watched and for all the positive feedback. I really appreciate it. Today, you are going to learn how to debug your ESP IDF application. Debugging is an essential skill for any professional firmware developer. It allows us to find problems and have an insight of what's happening during and after code execution. There are many different methods of debugging a microcontroller. Let's first take a look at the most common and simple one, which is using the serial terminal. Basically, this method involves adding the debug message that will be displayed in the terminal.
Okay, let me create let me create a new project. Actually, let me do that. New project. Uh, sorry about that. Okay, so let's do ESP IDF projects. Let's do JTAG debug com6, choose template.
This is the most simple way to gather information about the execution of our code, and it's useful if you don't have an external debugger tool. The ESP IDF has a wonderful capability of catching exceptions and misconfigurations, and integrates itself with Visual Studio Code without any extra line of code. Let's take a quick look on how that works. Through the idf.py monitor command, we can see on the terminal some information regarding the ESP32's initialization and partitions. Also, when there is an exception, the serial terminal shows a very complete report with the reason, the line where the problem happened, and even the call stack with the history of our function calls. For example, here, this bug was a division by 0 on line 44 of my blink.c file. By holding the Ctrl key and clicking on the printed line, we can make Visual Studio Code jump to the line where the exception happened. As you can see, this method is pretty straight. Forward. However, it has some limitations. For example, what if you cannot use prints at all, like inside of interruption callback? How do you get any information? For that, it's better to use an external tool. External debugging device use a common debug interface to communicate to my controller. And trust me, they are extremely useful for developing. There are many different debugging interfaces in the industry, such as SWD, ICE, and JTAG. Today, we are going to work with JTAG since it's natively supported by the ESP32 and it's very popular. And here are some cool things that we can do with the debugger. We can define the so-called breakpoints, which will stop the execution of our code when it reaches that point.
Oh, yep.
We can manually control the execution of our code by stepping in, out, and over functions. We have access to a variable list, where you can see the values for all variables and pointers at that time. We can even set a conditional breakpoint, which will stop the code if only a certain value is true, like a variable reaching a certain value, for example. And one of the most useful features, the trace breakpoint trap, which will automatically force a breakpoint when a crash occurs, giving us a lot of useful information. So in the next steps, I will show you which debugger to buy, how to connect your debugger, how to configure OpenCV, how to configure GDB, and how to configure Visual Studio Code.
Okay. I didn't know you need to buy more hardware to do that, though.
So, which debugger tool should I get? Where can I get one? There are many different debugging tools in the market. Expensive and powerful ones, such as this Sega J-Link Pro, which is aimed more toward professional applications. And also simpler and cheaper ones, like these guys, using the FTDI 22328 chip. This is a high-speed USB to JTAG IC that provides the debug interface for us. You can buy a debugger with this chip for less than $25 on the internet. There are many different board versions available, but to get started, I highly recommend getting this one called ESP Pro. I will leave the links in the description below. Alright, let's set up our debugger. Today I'm going to show the connections for the ESP Pro, since it's easy to buy one and it's the official debugger from Espressif. It doesn't matter which device you use in the end, as long as it supports JTAG, the pin connection for the interface should be the same. Connect ground to ground, 3v3 to 3v3, TCK to IO13, TDI to IO12. But first, in order for Windows to properly recognize the debugger tool and is responsible for managing the communicate button on the loaded the latest, let's create a file called task.json inside of that system. We first need to make sure that we have loaded the latest firmware build in and make the debugging process very fragile and frustrating, and start at address 1000. Follow the words in how you structure a project. At this point, because the program only.
Oh, okay. Okay, so I'm probably gonna need to buy another external hardware setup.
Now that we have all the physical connections ready, the next step is connecting the JTAG to OpenCD. OpenCD stands for Open On-Chip Debugger and is responsible for managing the communication with the debugger driver, in our case, the FTDI driver. Let's open a new terminal on Visual Studio Code. Make sure your environment is already configured for the ESP IDF. If you don't know how to do this, check my previous video here. By the way, as many of you pointed out in my last video, Visual Studio had an update and now we need to configure the IDF terminal in a different way. I will leave a link with the new instructions in the description. In this example, we are going to use the same Blink project as before, to keep things simple. In the new terminal, type the following command: openacd-f board/esp32 rover kit 3.3v.config. This configuration file depends on the ESP32 module being used. You may need to provide a different file if you use a different one. You can find more details on the IDF documentation. If you have connected your ESP32 properly and your driver is installed correctly, you should see this output. This means our debugger is wired properly and is up and running. By the way, in case your debugger is not connected properly, you may see something like this. And if your driver is not correct, you may see something like this. The next step is configuring GDB inside Visual Studio Code. GDB is the GNU Debugger, an open source debugging software used by Visual Studio Code to communicate with OpenCD. To do this, let's OpenCD is going to be established. Start debugger. Let's create a file called next.
Okay. Okay, I see. That's all I needed to know. Okay.
There's a high chance that you came here while, despite, it is important that you know what board you have, otherwise the correct hardware mapping will be impossible. So simply having a quote hello.
Wow. Okay, wait. Hang on 1 second. Version is this? What the heck? Good. Okay. Terminal. Oh shoot! Probably should show you guys. It's sorry. I was like maybe I forgot to switch screens, but there you go. I gotta download. I gotta get the debugging board because yeah. See what happens if I add a breakpoint, and then we'll recompile it again just to make sure. So let's do this. Let's see what happens if I do that. It'll probably not work because we need the JTAG debugger to do that. Yeah, definitely. Well, it did not work for obvious reason. Because we apparently need JTAG for this to work. Okay, I see. You got... Ah, okay. Alright, so we need a JTAG debugger. So we gotta buy some more, we gotta buy the prog board or some more hardware to do that, which I can't do right now, but okay. So anyway, that's out of the way. So let's go back to the roadmap. Let's go back to the roadmap. Let's go to this. Okay. So this is like more like debugging stuff we gotta learn later. So what else do we need? Testing? I think that's more for later. Make files, we covered that. Bash scripting, that's pretty useful. RTOS basics. We can definitely learn more about real-time operating systems, but that requires more like OS stuff, which we're probably gonna learn anyway when I start school. So like I'm not gonna bother spending too much time on that. So I think I might as well start my next project. Isn't that exciting? So I didn't realize that ESP-IDF is actually way more easier than I thought. So what should be my next project, right? You can, I want to try something like this. Like sending a text message to like my phone or something like that. First though, we're gonna need a web server, or when we need to set up the web server, then we need to like make it communicate with cell phones and stuff. So yeah. But I think we should also use external peripherals as well for the project. So yeah. So I don't really know what to do. I definitely want to do something that uses external peripherals. Something like, sensor, something so I can show that I know how to use I2C, essentially, right? That'd be pretty sick. And yeah, so I might think of doing another project like that. But this one's gonna be like a real project. not like a basic project. So yeah, okay. It's nearing the 26-minute mark, so I might just stay for like 4 minutes. Anything else to learn, really? UART, I squared C, SPI, JTAG. That's, we can learn that later. It's more like software engineering stuff. Embedded Linux, so where to learn embedded Linux. So like, let's so one more thing, control systems versus analog. All right, so yeah, today was a very short episode. Sorry about that, guys. I promise, like, I'll try to do more longer videos, but this summer it's just been really busy. But the fact that I'm even, for me, like, even if I code for like 30 minutes a session, I'm still happy with that. Because, like, see, like, the fact that I even, like, spent time learning how to try to do JTAG made me realize, like, okay, maybe we shouldn't proceed with JTAG and we can start with the project, right? So yeah, it's not a big deal for me. This stuff I've done on my own. This stuff, I've done a lot of this stuff off stream. I need to do that. UART, I squared C SPI, algorithm and data structure, design pattern state. This stuff I should definitely spend some time learning a little bit more, especially DSA. I don't, like, I have not really reviewed DSA that much. I don't plan on doing that, so probably more later on. What about state machines? This seems cool. This seems, probably should spend some time on state machines as well. Yeah, probably should also recap digital stuff, digital design and all that. Digital systems. There's a great book for one of my professors at university has first learning digital systems, so I think that's probably worth learning. But anyway, yeah. So thank you guys for watching. It is nearing the 30-minute mark, so I'm gonna end it here. I appreciate all the support. I see that people are watching my videos. I don't know why, but I guess if it makes people happy, that's great. So yeah, have a good day. I'll see you guys later.